Today I'm going to be discussing what are ontologies. So an ontology is a formal dictionary of terms, usually for a given industry or domain, that shows how the terms are related. In an ontology, terms are stored as object relationship triples, where the subject and object are oftentimes terms or concepts, and the predicate is the relationship or connection between these two terms or concepts. If you take a look at the diagram at the bottom left, you have two concepts, power plant and latitude, and you have the relationship or connection has latitude, which connects these two concepts together. By relating terms together, an ontology can create a densely interconnected web of knowledge in a given domain. How do ontologies address FAIR? Ontologies primarily address the interoperability aspect of FAIR, as they use formal, accessible, shared knowledge representation languages, including RDF and OWL, when they're describing the ontology. Ontologies are also findable, since each term and information within an ontology is assigned a unique identifier. Ontologies can be made accessible by publishing the ontology to an online repository and creating a standardized protocol for retrieving information from the ontology via their identifier. And ontologies can be made reusable by attaching clear and accessible data license relationships and information onto the ontology information. What about connecting terms from different domains? This is where something called a top-level ontology comes in. A top-level ontology is an ontology that can be applied to any field and hence is domain neutral. And the purpose of a top-level ontology is that it solves the failures of interoperability by introducing terminological consistency at the highest level. One of the most common top-level ontologies is the basic formal ontology, BFO. BFO is a top-level ontology from which over 440 public domain ontologies currently derive their terms from. And it's become so popular that it was recently recognized as an ISO standard. However, even with BFO, there is a need for a semantic bridge between the general concepts in BFO and the required specificity of material science vocabulary in domain ontologies. And this is where another ontology called PMDCO comes in, to serve as a semantic connector and to ensure that material science domain ontologies are interoperable and well-structured relative to one another. PMDCO is a comprehensive framework for representing knowledge that encompasses fundamental concepts from the domains of material science and engineering. The terms in PMDCO do connect to the BFO ontology, and PMDCO contains a library of over 200 material science and engineering terms and 30 relationships. And the purpose of PMDCO is that it can be used to create more domain-specific ontologies in the MSE space. PMDCO terms encapsulate a wide range of information about MSE experiments, from the provenance of samples to the calibration documents involved. And the figure on the right shows the hierarchical and custom relationships between PMDCO terms that was established in the most recent version of the ontology, which is version 2.0.7. So the MDS Onto framework recommends that all materials data science ontologies be positioned below PMDCO and other mid-level ontologies in the semantic web. Through this positioning, ontologies can easily achieve a semantic connection to one another. And the domain ontologies that are created through our framework, the MDS Onto framework, form the basis of the MDS Onto ontologies. Currently, we have a discrete number of domain ontologies, including the PV lifecycle, chemical discovery characterization, XRD, and we're currently working on expanding the domain ontologies that we are creating under the MDS Onto ontology umbrella. We publish all of our ontologies once they are created to the Fair Materials Find the Docs website, the link of which is shown on this slide. Currently on the website, there are approximately 30 scientific domain ontologies and JSON-LD files, each of which cover a different domain. There is detailed documentation for all of the ontologies that are created through the MDS Onto framework. And the purpose of the website is to make the ontologies accessible to the material science community and to ensure that all of the links that are mentioned in the ontology files resolve to their definitions online. The website also includes ontology visualization tools such as WebVal and a JSON-LD visualization tool called JSON-LD Playground. And I highly recommend that you check out the website sometime. We also published the MDS ontology, which is the umbrella ontology for all of our domain ontologies, to Map Portal. Map Portal is an open source initiative to standardize terminology across the materials domains, while not requiring people to change variable names. And Map Portal, one of the coolest features is that it allows users to map terms between different ontologies in Map Portal together in order to ensure that all of the ontologies in Map Portal remain in sync and up to date with one another. And hence, it is a major breakthrough in knowledge management. Thank you.